Hello, and welcome to this tutorial for BioXTAS RAW. In this tutorial, you will learn how to use RAW to make statistical similarity comparisons between different individual scattering profiles. To do this tutorial, you need to know how to load data into RAW. If you haven't done the tutorial for loading data, please do that first and then return to this tutorial. If you've been following through the tutorials one by one, you may already have some data loaded into RAW. If that's the case, please go to the Files tab and then click the Clear All button to clear that data. Additionally, if you have your plots displayed as, for example, just the top plot, show both plots by clicking on the Plot button down here, and change the plot to a log-lin axis if it isn't already a log-lin axis. We're now ready to get started with this tutorial. This tutorial uses the data in the damage data folder in the RAW tutorial data, which is available on the RAW website. I've now entered that damage data folder. I'm going to select all these data files just by shift-clicking, and I'm going to click Plot. You can see that these are now shown in the Profiles tab, as well as being plotted on the main plot. In order to see what's going on a little bit easier, I'm going to show only the top plot by clicking on the 1 button down here, the Show Top Plot. And then I'm going to change the plot to a log-log axis. This is because I know that the differences in these profiles are showing up at low Q. You can see that here, even in the log-lin plot, there's some differences down on the left side of the plot. And a log-log plot is going to emphasize the low Q region and make these differences easier to see. So these data are data collected from a lysozyme sample. They're 10 consecutive frames taken from the same sample. So naively, if you load them in, the first thing you might try to do is average them. So I'm just going to shift-click and average them. And when you perform an average, RAW automatically checks to see whether or not the profiles are the same. If it finds that there are profiles that are different from the first profile, statistically, then it gives you this warning here. So in this warning window, it's telling me that profiles 8, 9, and 10 might be different from the first profile, and we have to decide what we want to do. We can either cancel the average all files anyways, or average only similar files. In this case, I'm going to choose to average only similar files, and hope that that removes the effects of the radiation damage. If we want to be a little bit more careful about how we're doing this, we can actually look at the similarity test results for ourselves and try to be more discerning in our averaging. So with the files selected, I'm going to right-click and I'm going to select Similarity Test from the menu that appears. And that's going to open the Similarity Test window. So what this window is showing you is it's compared each file to every other file. It starts numbering them at 0 and goes consecutively from there. I'm going to expand out several of these columns so we can see all the information. So I'm going to expand out the file name 1, the file name 2, going to expand out the whole similarity testing window, and I'm going to expand out this probability column. So what we're seeing here then, let's take a look just at this top line. The first file compared is file 0, the second file is file 1. You can see that that corresponds to the file names of lice damage 1 and lice damage 2. So the test that we're using here is the CORMAT test, or the correlation map test. Right now, RAW only supports this test for similarity testing. And what this does essentially is it takes the two scattering profiles and it looks for the longest region of consecutive points where the scattering profiles don't cross. Based on how long that region is and how long the profiles are, it can calculate the probability that happened by random. So here, what we're doing is we have that length of the longest region. We have the probability that given a region that long, the scattering profiles are actually the same. And then, because we're doing multiple tests, we're applying a multiple testing correction. You can see it up here. And so this is the multiple testing corrected probability that the profiles are actually the same. If you want to get a quick look at what's going on in the data, you have two options here to highlight different thresholds in the data set. This one lets you highlight things that are less than a given threshold. So if I check that, you can see it shows me immediately that files 8, 9, and 10 have a probability that they're the same that is lower than the threshold. This is what was reported when we tried to average the files. You can uncheck that. You can also highlight things with a probability higher than a threshold, and you can change these thresholds if you want. For example, I could change the threshold to 1 or 0.1. The other thing we can do if we want to be particularly careful is I can turn off the multiple testing correction. And then I can look for where things are the same. I can also make the threshold maybe more stringent, say 0.3. And you can see if I do that, there are a few files that it didn't warn us about that maybe we shouldn't include in the average. Looks like file 1 to 5 are all very similar, and after that there's less probability that they're the same. In this case, I happen to know that radiation damage is something that increases with the amount of exposure, so we expect it to get sequentially less similar as we take more exposures of the same sample, if any damage is happening at all. So in this case, it seems very reasonable to say that we should exclude data 6, 7, 8, 9, and 10. If you want to save the results of the comparison, if you want to save this table, you can click the Save button. That'll let you save a CSV with all the information in it. It's also important to point out that this method is not only implemented in RAW and was not initially implemented in RAW. So if you use this method in your analysis, you should cite the appropriate paper, which is given here in the How to Cite button. We're now done, so I'm going to click the Done button. If we wanted to be particularly careful, given what we know about radiation damage and what we just observed, we would average just the first 5 datasets, or first 5 images in the dataset. By selecting them and clicking Average, you see that we don't get a warning this time. And if I hide all of the individual profiles, we can compare the two averages. We can see that they're really quite similar, but the orange is a little bit lower than the blue out here at low Q. With that, that's the end of the tutorial. You should now know how to do similarity testing in RAW.